Hello and welcome back. This is part 8 of a series covering the Hare programming language, and this video is actually part 2 that covers error handling and pattern matching. Now, in this video, we are going to jump back into the tutorial and start calling standard library functions and actually handling real errors in our program. If you're just now joining us, I would suggest watching the two previous videos, which are assertions and tagged unions, and that's going to give you an introduction to the basic features that you need, and then also the first part of pattern matching and error handling, and I break pattern matching down very progressively so that you can understand it. So if you find this particular video a bit hard to understand, please go back and watch those previous two. And I would also like to say that, I'm still learning programming in general and especially systems programming. So if I make a mistake, please feel free to correct that down in the comments. I definitely don't want to be putting out incorrect information. Now, before we jump into real error handling in our programs, there's one thing I would like to highlight. And this comes from a blog on the Harelang website by Drew, and it's called Hare is a Boring Programming Language. Now, the reason I would like to highlight this is because error handling in Hare can get to be a little verbose, but there's a reason for that, okay? And that is right here. So let me just read this one paragraph, right? It's this one right here. So most Hare programs just need to be written once, and then they can be relied upon to do their job for a long time. We don't often find ourselves having to revisit the Hare code we write. This differs from a common notion in free software where the activity of a project is used as a proxy for its quality. Instead, the ideal Hare project completes its goals and stops, fixing bugs and adding minor improvements in the long tail. So this is the reason why error handling can get to be a little verbose, because the philosophy that Hare really follows is that it's a systems level language that really kind of follows the Unix philosophy of do one thing and do it well. And these programs that you write are designed to properly function for a very long time. Okay, so I just kind of wanted to point that out before we get started. Okay, and then also, before we jump into the specific part of the tutorial that we're going to deal with, I would very briefly like to revisit an example that we've already done, okay, before we introduce new code. Okay, I'd like to show you error handling with code that you're already familiar with, so it's not overwhelming. And that's going to be this simple hello world program, and we're just going to be handling the errors for print line. Okay, so let me go ahead and jump over into the text editor, and let's go ahead and I'm going to show you how you handle errors with the print line function. So before we get started, let's go ahead and pull up the Hare doc for print line, and you can see here's the signature. Here's the return value that we're concerned with. So size is our success, and IO error is a failure case. Okay, so these are the two types that we need to handle. Okay, and I'll show you the idiomatic way that this is generally done in Hare. Okay, so we have our match expression, and we open it, remember, like we're calling a function, and inside of this is where we actually call our function. So we'll just say hello world, right, like KNR. That's where this comes from. And so you can see what's happening here. We have our match expression, and we're calling the printline function from the format module. Okay, now the first error case we want to handle is size. Okay, now this is only something you're going to know if you have prior experience programming. So, again, this is just something that I had to kind of figure out myself by really looking at a lot of idiomatic Hare code. So what we generally do in Hare to handle a size success is we would say, I'm going to use caselet syntax, and I'll just abbreviate it size, okay? And generally what we would say is something like assert that size is greater than 0, okay? And what this means is that if this function returns a size of 0, which means that it failed to write everything correctly to the console, then we're going to have an assertion, okay? And we could say something in our code like this, right? An unexpected short write, okay? Now, if we look at the next error, this is IO error. So if we pull that up, we can see any error which may be returned from an IO function. Okay, now I'm just going to handle this one error in one specific way. So I'll use caselet syntax and abbreviated error. Okay, and the type that we're matching against is IO error. Okay, and then I'm just going to use the unformatted version of this function. So if you remember, there is fatal and fatal F. I'm just using the unformatted version, okay? And I'm going to use the IO string error function and pass in our error, okay? And this right here is pretty much as idiomatic as you're going to get when it comes to Hare, okay? So go ahead and pause this if you need to look at this code real quick, and let's go ahead and run this program. Unresolvable identifier. Okay, so what I failed to do is import the IO module. Okay, so let's import the IO module because you see we're matching against it here, and we're using the IO string error function. Okay, so let's import IO, and let me clear my screen. And you can see that it prints just fine. Hello world. Okay, now what I want to show you is you can see. Now if you remember when we used the error assertion operator on this and we tried to write it to dev full, it crashed our program, okay? Because that's what the error assertion operator does. It crashes your program if an error does occur, okay? Now let's look and see what happens when we try to write our program to dev full with proper error handling, okay? And you can see our program terminates gracefully and prints a proper error message instead of just crashing, okay? So hopefully that is enough to kind of build you up so that when we look at the tutorial now, you have enough experience with error handling that this is not going to be overwhelming. Okay, that's kind of the goal that I'm trying to do here in building you up towards error handling and pattern matching. Okay, so now let's go ahead and jump back into the official tutorial. Okay, so now to continue on, you should be on this part of the tutorial. It's under handling errors, and it's this first part called a few words about error handling. And if you'd like to just go ahead and copy this and put it into your text editor. And let's just go ahead and get started. So many operations can fail. For instance, writing a file could fail if the disk is full, or a network connection could fail if the Ethernet cable is unplugged. In Hare, it is mandatory to consider these cases. In prior examples, we have used the error assertion operator, which causes the program to crash when an error occurs. Let's explore some more ways, more effective ways, of dealing with errors. So this program uses OS create to create a file named after the first command line argument and writes hello world to that file with IO write. Both of these functions can fail for a variety of reasons. You can try out some failure cases like so. Now let's go ahead and look and see what this is doing. Okay, so we're using osargs to get the first command line argument, technically the second because the first is implicitly passed as the name of your program. Then we're creating a flag that is going to be passed right here, okay, to OS create, and that is write only or truncation. What that means is if this file exists, it's going to open it in write only mode, and if it does not exist, if it exists, it's going to truncate it. Now, what we're doing is we're matching, okay, and we're using OS create right here to create this file. And you can see we're passing in path. So what it is, it's going to be the first command line argument, whatever we name it, whatever we pass in. Okay, and this is the permission in octal. Okay, this is standard Unix permissions for user, group, and other. Okay, and this is where we're handling the error. Okay, now on success, OS create returns a valid file handle, and that's what we're doing. We're yielding it back to this variable right here, okay, to be used later on. Here we're handling a specific error case of errors no access, and here we're handling a file system error, okay. So go ahead and copy and paste this into your text editor. We're going to try this out. You can see it says error handling is very important in Hare, so we're going to go over the sample in detail in the next few sections. So we will be breaking this down more, okay? So go ahead and copy and paste this into your text editor, and let's go ahead and go over this. Okay, so here we are in our text editor, and let's start with the first part. We're using osargs, which is a slice, and we're taking a command line argument and placing it in this variable path. Now, here we're creating some file system flags. Let's look at OS create real quick, okay, with HareDoc. Now, you can see here's the function here, okay, and it takes a string, right, which is a path, that's the file we're creating, a mode, and then here are the flags. Now, what this means when you have the equal and then a specific value, this is passed in by default to your function. Okay, so I don't know if this part of the tutorial was made before this feature was added to this function, but technically you don't have to do this and pass this in. We could delete this line and delete this argument from our function, and it would still be the exact same if we wanted to. I'm not going to do that because I don't want to cause confusion, okay? So we're passing in the path to OS create, which is what's going to be taken in right here as a command line argument. These are Unix file permissions. So 4 is read, 2 is write, and 1 is execute. And this is user, group, and other. Okay, that's something you're just going to have to look into. It's something you're going to have to become familiar with. Okay, so if we look at the first case, of IO file returned by our OS create function. This is our success case, and this is a file handle, okay? And the error case is fs error. Let's go ahead and look at that. Okay, because what this means, it's going to help you understand the two other entries in the match expression, okay? So I believe it's this here. Let me go ahead and look at it. Okay, so our second case, so our success case, we're yielding the file handle back right here, okay? Our first error case that we're handling is a specific error case, okay? If we look and see at fs error, we could just handle just this one error within our match expression, just like this, okay? But in this case, you can see this is one of the possible error types under fs error. So this is a specific error, okay? And what this means is that we wouldn't have access. Say we didn't have the proper permission, okay? We would get a no access error, okay? And that's what this specific error is handling. You can see it right here under fs error. So what that means is we're just handling this error right here. And remember, fatal F is the formatted version, and so it's saying error opening, and we're passing in path, which is here, so it's going to show the file that we're trying to create, okay? Now, here is where we're handling any other file system error, okay? We're using the formatted version of this function. Here is where path gets passed in, so that's going to be whatever file we're trying to create, and that's just, it just helps with readability, okay? And then here on this part is where we're using the string error function to get this error if it does return any other file system error besides no access, okay? And we're stringifying it with our string error function and printing it, okay? Now, if we look and see at OS create, now it doesn't, now it should tell you, I think it should tell you that you have to close this. Now, my advice is, there's no replacement for learning C, okay? And if you're coming from C, you would know that you have to close this file. I think it would be helpful if it stated it in the documentation here. But the point is, we're deferring the IO close and closing this file. Now, if you notice, this can also fail. But if we look at the documentation for this, and if we were to look at the standard library tutorial, it says that it's okay to use the error assertion operator on IO close because it has a low likelihood of failure, okay? So you can see right here, closing a file handle can fail only under certain conditions, okay? So with some things, right, like IO close, and this is why I'm writing my book, and this is all the type of stuff I'm putting in there, right? Because with some functions, right, like your print functions, it's generally okay to use the error assertion operator because the likelihood of functions like that failing are very low. Now, if you wanted to handle every single function as a success and failure, please feel free to do that. Okay, but there are some cases like this where you don't necessarily have to. Okay. Okay, now what we're doing here is we're calling strings to UTF-8, and we're basically, this is a UTF-8 encoded string right now that we're passing in. It's just a string literal, and what this function is going to do is turn it into a byte slice, okay? So let's go ahead and look at that, because that's what we're passing in right here to our IO write function. This is what we're actually writing to the file, but we're not writing it in UTF-8 format necessarily. We're turning it into a buffer, okay, into a byte slice, okay? So let's look at strings to UTF-8. And you can see it converts a string to a UTF-8 byte slice, okay? And you can see the return value is borrowed from the input, okay? So if we jump back over into our text editor, okay? Now, so that's right here. Let's look at our IO write function now, okay? Because this is what we're actually pattern matching against, okay? Let me clear my screen. Okay, and you can see that it writes up to lenbuff bytes to the handle. Okay, now anytime you see this, okay, I don't know if I've explained this before, but this is a construct within the language that you can look up with HareDoc that you can use. And when there is no module prefix, it means that it comes from this module, okay? Let me show you another example of that. I don't want to confuse you, but I need to show you this so that you understand HareDoc, okay? Let's look up, I'm trying to think of an example. Okay, so here is another example. You can see the type, right, formatable, but now size is a built-in type, so there's not going to be a module prefix. But formatable is actually, oh, sorry, formatable. So you can see when there's a function or a type inside of HareDoc that looks like this without a module name before it, it's in this module, okay? So you can see for print line, there's no FMT before this, it's in the FMT module. You see if a function or a type is in a different module than the one you're looking up, it's going to have the the module prefix to it, okay? So let me show you another example of that. I just thought of this off the top of my head. Okay, see, so you see this is an actual, I believe this is a function. We can look it up. This is a function, but you can see there's no module prefix, and that's because it's in this module here, okay, that you're looking up. I'm going to put this in my book, and again, these are the sorts of things that, you know, what might be obvious to the language designer or experienced programmers might not be so obvious to someone who doesn't know these sorts of things, right? And these are the kind of lessons that I've learned. Excuse me. Okay, sorry about that. It's a busy day outside. These are the types of lessons that I've learned that I'm distilling in my book, okay? Because Hare is a great language, but it's still in development, and the documentation at the moment is really kind of only meant for developers. And so these are the type of lessons I'm trying to distill in my book. So let me show you what I mean, okay? So you see, we're looking up OS create, and this doesn't have a prepended module, okay? So we would say, okay, so you see, since this doesn't have a prepended module, it's in the OS module. See, HareDoc OS make file, okay? This has a prepended module, so it's in a different module, you see. So hopefully that's understandable, okay? Now, let me try and figure out exactly where I was. Okay, so we want to look at the IOWrite function. Okay, so we can see it takes a handle and a buffer, and on success it can return size, and on error it can return error. Now again, okay, this means this is not prepended by a module name. So what this means is Hare.io error. These are sort of the idioms of the language. There are some things you're going to have to figure out yourself. There are things you're going to get comfortable with the more that you use the language. Okay, but again, these are the sorts of things I'm putting in my book, because how would you know that? You wouldn't know that. You certainly wouldn't know that just by looking at this function signature, right? So perhaps this could be improved, in my opinion. Um, but at the moment, it is what it is, okay? And I'm just trying to help you understand this as best as I can, okay? So here's our IO error, and this is the error that can be returned from the IOWrite function, okay? So what we're doing is we are first handling an error case. Now, it's certainly debatable what you should handle first, your success case or your error case. Some would argue it doesn't matter, because if you have a successful return, that's going to be handled. Um, but that's certainly debatable, and that's something for you to consider in your code, okay? But in any case, in this case, we're handling the error case first. So we're using the caselet syntax and stringifying it right here with the IOStringError function if this fails to write successfully. Okay, again, we are turning this into a byte slice and passing it into IOWrite, which is going to write it to our file that we created here. Okay, with path oscreate. Here's our file handle. Okay, now you can see that the success case looks very similar. It looks exactly similar to nearly exactly to what I showed you with the printline function. Okay, so we're just capturing this return value of size, whatever, however many bytes it writes, and we're asserting that it is equal to the length of the buffer, which is right here. Okay, and if it's not, it's going to be an unexpected short write. Okay, so that's what's happening with this program. It looks very verbose, but all we're doing is we're passing in a command line argument, opening that file, and then writing hello world. Okay, it's very simple, but again, this is why I pointed out in the very beginning that Hare code error handling can get to be pretty verbose at times, but there's a reason for that. And in the next section or two, there is a way to shorten this, and that is to propagate errors up the call stack, and we will look at that. So I guess let's go ahead and run this program, okay, and see what happens. So what we want to do, let's run it. Now we want to pass something in. Let's just say hello, okay. Now you can see here is our hello file, and if I cat this file, you can see it has hello world. If I were to open it in my text editor, here it is, hello world. Okay. Now you notice I didn't put a file type on the end of this. Okay, that's fine. If you wanted to, you could. So that is this function, and that is this program, and we can let's go ahead and look at some of these, do some error handling on this. So we already did this first case. This should work. Okay, I didn't use txt at the end, but that's fine. So let's go ahead and try this. Okay, so we're going to make a directory, okay, named test, and then we're changing the permission on it. We're revoking the write permission on this directory, okay? Let me just go ahead and remove this file. Okay, now you can see, here's the test directory, and if I list it, you can see the permissions, okay? Now let's go ahead, and what we're going to try and do is create this example file within this test directory, okay? And so let's go ahead and say test and then example.txt. Okay, you can see error opening, access denied, and that's because we revoked the write permissions on this directory. Okay, and now let's try and write this to dev full. Okay, let me clear my screen. How is it how are we calling that? Okay, so yes, we're just calling that as the argument. And you can see error writing file, no space left on device. Okay, so please feel free to go back and watch this portion of the video. And let's go ahead and move on to this next section, which it's the same exact program. Okay, so if you didn't fully understand all that, that's okay. We're going to be breaking this down even more in this example. Okay, so now you should be on this next section, handling errors with match. And this is the same exact program, and it's basically just going to explain what's happening. Okay? So it says, let's look at the signature for OS Create with Hare doc. And it's right here. And remember, we did previously look this up. And you can see it returns IO file, which is our file handle on success, or FS error on a failure case. This function can return one of two possible values. And you see this is a tagged union. It returns can return one of these types. This function can return one of two possible values, an IO file if the file was successfully opened, or FS error if not. You can look up both of these types with HareDoc if you like, and your attention is especially drawn to FS error. This type is a tagged union, which represents each of the errors that can be caused during file operations. So let's very briefly pull that up. And you can see, so it's an error type. You can see it's prepended with the error flag, and it's a tagged union. This is every possible error type that makes up FS error, okay? And remember, we handled one specific error and then every other possible case. But this is a tagged union, so this is one type, another type, and so on, okay? One way of handling these errors is with the error assertion operator, which you already know how to use. A more elegant way is to use match. A match expression takes an expression between its parentheses, which can return one of several types from a tagged union, and each case handles one of these types. The first case in this example is the successful path, which we'll talk about momentarily. The second case handles a specific error, errors no access, and the third case handles any other errors. So it's referring to this right here, okay? So again, the successful case is a file handle, and we're yielding it back to this variable, okay? They just happen to be named the same thing here and here. That's really just arbitrary. Here is our errors no access, which if you remember, if you see is one type of the tagged union of FS error, okay? So that's the error case we're handling here, and we're just printing something simple. This returns type never, so this will terminate our program. Same with this. Fatal F, this is the formatted version. Both of these will terminate our program and print this message. So this is just a custom error message. You can see we're not capturing any type of value and stringifying it. We're putting in the path right here, and so it's going to list the file that it could not open if we get access denied. Now for FS error, let me see what it says here. Okay, now for FS error, we're capturing the actual error value right here in this variable, and we're stringifying it with the FS string error function. Remember, since we're printing an error type of FS error, we're using the string error function that's inside the FS module, okay? And the path gets plugged in here, okay? And then our error message right here, okay? The caselet syntax is used to bind the value for each case to a variable. In the first branch, this value uses the yield keyword to yield it to the parent expression, which causes it to be returned, and you see it's in quotes, in a manner of speaking from the match expression. This assigns the desired IO file value to the file variable. Okay, and again, that's right here. So when we pattern match against our successful case, which is IO file, we're capturing it here in this variable, and we're yielding it back with the yield keyword to this variable here. Again, these just happen to be named the same thing. These could be completely different, okay? The third case binds FS error to an error variable, then passes it to FS string error to convert it to a string that can be presented to the user in an error message. This is a standard pattern in Hare. Most modules will provide a string error function which stringifies all of the errors which can be caused by that module. And that would be right here. Okay? And then again, we are deferring the close of IO file. If you wanted to manually close it down here, you could do that. But that's one great thing about the defer keyword. And again, we are creating a string literal here, passing it to strings to UTF-8, which creates a byte slice, okay? And we're using the IO write function to write that, which is here, to our file handle, which is here, okay? Then we're handling these error cases, same thing. Okay, IO write can either return size on success or IO error on failure. And we are just stringifying the error message here and printing it here if we do get an error case. And again, for size, we are just asserting that everything that we want written, okay, which is right here, is actually written to this file. Okay, and if it's not, it's going to be an unexpected short write. Okay? So that is error handling with pattern matching. And I know this can be quite confusing if you've never done pattern matching before. In C, you don't have to handle errors if you don't want to. But again, that is explicitly what Hare is trying to do, is improve on C in a number of ways, and Hare has mandatory error handling. So this is, in order to be comfortable and effective with this language, you're going to have to get used to using the match expression and handling these errors in various ways. Now, error handling itself is, I'd say, a pretty in-depth topic because there's no one specific way to handle errors, okay? Here, for example, we're just terminating our program and printing something to the console. But you could just as easily log this, okay, to a file if you wanted to, and then terminate your program. You could log it and then take some other action. Okay, so that error handling really just depends on what you're trying to do. There's no right or wrong thing to do necessarily. Maybe you encounter an error that doesn't need to terminate your program, and in that case, you can just keep running. Okay, that really depends on what you're trying to do, and I would say that comes with experience. Okay, so that is error handling with pattern matching. And again, please reach out if you need some help. I will be more than happy to help you if I can in the comment section, or if you would like to jump on one of the official Hare spaces, whether that's an IRC channel or the mailing list, to get help. And so if you need help, please do reach out. Okay. Excuse me. If you need help, please reach out. Um, and let's go ahead and move on to the next part, which is going to be propagating errors. Okay, so to continue on, you should be on this section, propagating errors. And go ahead and copy and paste this into your text editor, or you can feel free to type it in by hand if you would like. And what this is the exact same program that we just did here, okay? Except we're wrapping all of this functionality inside of a function, okay? And that's this write hello function right here. Okay, so let me go ahead and explain what's happening here. So you can see it says it is cumbersome to use match to enumerate every possible failure for every function that might fail. To make it easier to deal with errors, I think this is called the error propagation operator, is generally useful. The purpose of this operator is to check for errors and, if found, return them to a higher call frame. If there are no errors, execution will proceed normally. To use this functionality, it is necessary to establish some error handling code somewhere in the program. In this sample, the main function is responsible for all error handling. In more complex programs, you may handle various kinds of errors at different levels throughout the program. An HTTP server, for instance, might have some logic to handle configuration errors by printing a message and stopping the server, but could handle errors related to a specific client by sending them an error response or disconnecting them. OS create and IO write together can return either an FS error or an IO error. So the result type, now in Hare we generally call the return the result. So that's all this means. The result type for our write hello function is a tagged union of either void, nothing indicating success, FS error, or IO error. So that's right here. Okay, here's our return type of a tagged union. A void, FS error, IO error. We can use the error propagation operator to return these errors immediately and extract the useful types from the return values of these functions and handle both cases in main. Okay, now on my screen this is a little small. I can try and make it a little bigger. See, but that's what happens when I do. Let me, okay, so sorry about all that. Trying to see, where did I leave off? Okay, I'm really sorry about that. Okay, let's go ahead and jump over into the text editor and look at this program. So I have this here in my text editor, and this is the main part we're concerned with here at the moment. Okay, and that is the return value of this function write hello. And as you can see, we have our success case, which is void. Now this could be whatever you want it to be, okay? And if you wanted to return an integer on success, I think you could be able to do that, but we're just not returning anything. What we have to handle are the error cases for OS create and for IO write, okay? Now, OS create can return a file system error, so that's what this is here, okay? IO write can return an IO error, so this function can return one of these possible values. Now you can see right here, okay, this question mark, and this one right here. So these are the errors that can fail. And what this is saying is if this function fails, OS create, it's going to return an FS error, okay, and propagate that up the call stack to our match expression here, where we're actually calling write hello, okay? So again, this is the same exact program that we ran before. We're just wrapping all of the functionality into a function and propagating the errors, okay? So here's our success case, which is yield. Now when you use yield like this, it just returns void, okay? So this is the same thing as saying void, okay? Return void. Now here is the first error case of a file system error. And again, we're just plugging in the path right here, and then here is the error case that we're stringifying, so we're capturing it here and printing it here, okay? And here is the IO error that can be returned from our IO write function, okay? And you can see we're using the error propagation operator. If this fails right here, if this fails in place right here, it's going to propagate this through this error type up the call stack when we call our function here, and we're handling that error here, okay? We're pattern matching to see if that's what happened. So what this does is it propagates it outside of this function, okay, through one of these error types that you have to define. If this can return, you know, if we had a different function and it could return a possible error type, you have to specify when you create this function that one of these error types can be returned by this function, okay? So if OS create fails, it's going to return FS error, and if IO write fails, it's going to return IO error. And again, here's our success case. Okay, so let's go ahead and run this program. And I'll say hello.txt. Now let me list my files. I still have this test directory here. We could, if we wanted to, you know, try and do some error handling with this. So if I count this file, you can see it's hello world, okay? Now, so that's on success. That is this case here, okay? It returns void on success, and when we just use the yield keyword by itself, it's returning void, okay? Now, let's go ahead and try. Let me do this again. I will revoke the write permissions for a test, okay? And list that here. And let's go ahead and do example.txt. And you can see permission denied, and that's because we revoked the write permissions on this directory. Okay, now if we try and write this to dev full, okay, no space left on device, okay? So this is the same exact program as before, Except now, you can see it's much less verbose, okay? So it's much more concise, probably a little bit easier to read, okay, and probably a little bit easier to reason about just from first glance. But you can see, in my opinion, Hare is very readable. This is all very readable. If you were looking at this in C, I mean, C programmers are notorious for using one, two, three letter, variables for things everywhere. And not that C is not readable if you're experienced in it, but this is just, in my opinion, this is much more readable than C, and it's easier to reason about, in my opinion. In my opinion, Hare has far less cognitive load than C does, okay? And so this is a way, again, we're using the error propagation operator, okay, in order to propagate whatever error that these functions are returning. We're propagating them up the stack when we call this function, and we're handling these errors in place. So you can see how much more concise and readable this program is, or might be, compared to the previous version of this, where we handle every possible error in place with these functions as we're calling them. Okay, so go ahead and experiment with this feature. Um, you know, the only way that you learn programming is to try things. Okay, you're not going to learn by just watching these videos. So I encourage you to, use this feature, get used to it. This is very common in Hare, right? This is very idiomatic to propagate errors. Again, depending on what it is, depending on what you're trying to do. Okay, so that should be it for this video. I don't want this video to be too long, and so in the next video I will cover some more of these sections, but since I already made part 1 for pattern matching and error handling, I wanted to do part 2 and keep it somewhat concise and approachable and hopefully not very long. So that's it for now. Please have a good and safe holiday season, and I will try to get the next video out as soon as I can. So thank you so much, and thank you to the subscribers that I have, the old ones and the new ones, and have a very nice day.